Hello everyone, today's topic is cooling of transformers and methods of cooling. Let us understand why the transformer has to be cooled down and what are the different techniques of cooling the transformer. First of all, what do you mean by cooling of transformer? So why cooling of transformer or why it is required? Now, cooling of transformer is the process in where the heat which is generated within the transformer while it is operating has to be dissipated or it has to be treated to the safest value. That means we're operating a transformer attains the heat has to be dissipated to the safer value. In order to achieve this, there are different techniques of cooling methods installed in a transformer. Now let us imagine there is no cooling technique is available, then the heat which is generated within the transformer gets accumulated and the heat will become more and more damaging the windings of the transformer. Hence, the transformer has to be treated in order to cool it. So, the major factor for generation of heat is because of the various losses which we have come across like hysteresis loss, then copper loss, that is load losses. Now, because of this, the heat generally generates. So, this has to be cooled down. Now, there are different types of cooling we come across. The first and foremost one is air natural, air forced, oil natural, and oil air natural is called as OAN. Similarly, oil natural, air forced, oil forced, air forced, oil natural, water forced, oil forced, water forced. These are the different techniques we have for cooling of the transformer. Let us understand one by one in detail. Now, as I said, as the temperature of the transformer generally continuously increases rapidly, so it is going to degrade or damage the insulation of the transformer, and also it will result in the damaging of various parts like your windings, or even the transformer can fail in operation. So it is very much suggestible to for proper removal of treatment of heat. Heat has to be removed continuously. So if you remove the heat then and there, the efficiency and the life of the transformer can be improved. So different cooling techniques for the same will be employed. Now, majorly there are two types of cooling were used. One is called as dry type and the other is oil immersed type. Now, for the cooling of transformer, the following cooling methods will be used. As I said, we mentioned there are different techniques: oil natural, air blast, air forced, oil natural, air natural. Let us understand one by one in detail. When we take dry type transformer, so under dry type transformer we have air natural and air forced. Here we are not immersing within the oil. That's why we call a dry type transformer. It is air is forced from the outside. There is no oil here. That's why it is called as dry type. Whereas when we come across oil immersed type, so you can see here everything is oil related. Oil natural, air natural, along with the oil, air is passed. Oil natural and air is forced here. Oil forced with air forced, oil natural, water forced, oil forced. So all these are comes under oil immersed type. Now let us understand one by one in detail. What is air natural? As the name suggests, air natural, we know that the natural air which is available in the atmosphere is allowed or passed on to the transformer to take out the heat by the circulation of natural air through the surrounding air itself which is available. Here you are not forcing the air but the natural air which is allowing. This type of cooling is very much suitable for a smaller transformers, or we can call this method as self-cooled method also. So generally this is useful for up to 1.5 MVA. Now when it comes to air forced or air blast, as the name suggests, air is forced here. Here in this method the air is accumulated or with the help of a pump, or air is circulated with the force air method. Now with the help of the fans or a blower, high velocity of air is forced onto the transformer cores and the windings, so that the temperature inside the transformer is automatically circulated outside slowly to a safe level. So you can also activate an alarm and you can check what is the maximum temperature that can be attained, and whenever the alarm rings indicating that the temperature is more, you will be automatically switch on the air forced method. So this type of method can be used up to 15 MVA. Now next, second type is oil immersed. So oil immersed, first one is oil natural, air natural, that is ONAN. Then you can observe is ONAN technique. In ONAN technique, you can see the diagram here. Here, natural convection process is used for the type of cooling. So you can see here, you have a radiator, you have a conservator. Now, the assembly of core and windings are, you can see here the core and the windings. Assembly, here you can see here, this is your core and this is your windings. They are immersed in the tank, which has a conservator and a radiator. Now, in this process, the assembly of core are immersed. As the core and the windings gets heated up, the temperature of the oil in the transformer generally rises. Now, as a result of that, the oil moves upwards. You can see the oil moves upwards and flows from the upper portion of the transformer tank. Now, because of this, hot oil dissipates heat in the air by natural convection and conduction process, and the oil here gets cooled by the circulation of natural air, and which is passed on to the radiator again for the use of the transformer. So this type of method or cooling technique is very much useful up to 30 MVA. Next one is oil natural or air forced. Here the only change is everything remains to be same in the above technique, but here oil immersion technique is natural, but the air is forced from the outside external fans in order to cool it effectively than the previous technology. And the last one is oil natural and water forced. As you can see here, water forced means the immersed transformer in the oil and the water is forced outside the core in order to cool it down at very faster rate. So you can see the diagram here. For the purpose of cooling here, we have used water pumps externally. So the water pumps cools the generated heat. So this is all about cooling of the transformers. Thank you.